Hey guys, hoping all is well with everyone. So in this video we're going to be looking at section 2.2, which is addition, reviewing the standard algorithm, composing tens. Now this is going to be kind of a continuing lesson from 2.1, as we're going to see that there is going to be some estimation in some of our practice here. But before we jump into it, just to get us refamiliarized with some vocabulary here, we don't really see the word algorithm very often. To be honest with you, when we do mathematics in a lot of situations like operations like of addition, we use the standard algorithm as second nature. We don't really think about it, so it's not like we would be like, okay, now I need to use the standard algorithm of math to calculate this value. We don't usually think that way. We kind of just add the numbers together to find and calculate our answer. But just to review the terminology here, an algorithm is just a set of rules or processes that can be used in calculating or problem-solving related situations or scenarios. So we're going to be using that standard algorithm in this section to calculate and add some more higher number addition that will involve what we'll see as what is known as carrying. But let's go ahead and kind of look at the step-in question. So it says, what does this table show? So if we look at the table on the right, it is the theater attendance split over the weekend into 2 days, Saturday and Sunday, but it's also split into a time of day, being morning and afternoon. So this is a 2x2 table with the theater attendance on the weekend in morning and afternoons. So it says, how can you calculate the total attendance on Saturday? So the turkey here is saying I can figure that out in my head. If I take 115 plus 70, that equals 185. And then he took 185 and added 4 and equals 189. So his strategy is to take those numbers and make them more friendlier numbers, add them together, and then kind of add on those kind of outcast or kind of non-0 or 5 based numbers that are a little bit more challenging if you were to add them to other numbers first. So that's the strategy he took. Okay, gobble gobble. How could you calculate the total attendance on Sunday? So the cat here, it says Hunter used the standard algorithm, or addition algorithm. He followed these steps. So let's look at what he did here. So recall that every value or every number has multiple place values. Unless it's a one-digit number, then it only has the ones place. But remember that your place values go from right to left, and they increase from right to left. So ones is going to be your first place value, and as you go left, you get to your higher place values. So what he did here was he broke up the problem into kind of columns, and he's going to add those columns together. The biggest thing here that you have to remember is that you can only have one number in each place value. Because of that, this concept of rounding is very, very crucial and important. So what he did here, what Hunter did, the cat with the wrist headband, was he added together those columns, but he did what's called carried. So when we carry, 5 plus 7 is 12. But again, we can only put one number in each place value. So we have to put the ones value of 12, being 2, in that ones value. What this 1 represents is a group of 10 ones. So it represents a group of 10 from the previous place value that was added. So for example, 5 plus 7 is 12, and 2 is the ones value. So if you put 2 there, we have 10 groups of 1 or 10 ones left over. So that's what this 1 represents. But now that it's in the tens column, we can add it in the tens column and then add it down the column. So 1 plus 2 plus 6 is 9, which is where that 92 comes from. And then for the last step, he just brought down that 1 because there was nothing that was carried over, because that 9 is a one-digit number, and we didn't have to carry anything over, no groups of tens or anything like that. Okay, so let's look at these questions here. So what Hunter did in each step was he calculated the sum of the numbers in each column being the place value, specifically one place value at a time. And he carried over any times necessary where the sum of two digits or two numbers was a two-digit number being 10 or greater. Okay? Excuse me. So what does the red digit in the tens column mean? Excuse me. I bolded it in black just so you can see it a little easier. But oops. But what these ones that are in the tens column that I'm bolding in black represent is a group of 10 ones. Because if you think about it, we put the 2 there, and then if we put 2 from 12, we have 10 left over. So we have 10 ones left over. But again, we have to carry that 1 over because we cannot put two numbers in a single place value. So that's where that 1 represents. That 1 represents one group of 10. And this could happen in multiple place values. It doesn't just have to be from the 1s to the 10s place. It can be other places as well. And I'm sure we'll see that in the step up question. And what is another way to add these numbers? Another way that you can add these numbers together, another way is kind of what the turkey did. I don't know why the turkey doesn't have a name. But what you can do is make the numbers a little easier for you to add. So you can say, well, 125 plus 67. Well, I know that 125 plus 60 is a pretty easy sum to take. That would just be 185. And then I can add 7 to that, and I would get 192, just as Hunter did. So another way that you can add numbers like this that are a little bit non-friendly to begin with is to make them friendly, and then just add on those kind of numbers that make them less friendly in the first place at the very end. Okay? So let's look at the step-up question here. So it says, number 1, estimate each total, then use a standard addition algorithm to calculate the exact total. So this is going to be great practice for us with rounding, because we're going to first estimate. And for all of these, what I'm going to do is I'm going to estimate to the tens place. I figure we got a lot of good practice with the hundreds and tens place last time, so I'm going to keep everything to the tens place this time. So we have 458, and I'm just going to be doing this in the paint program on the left top corner here. So 458, I look at that 5 again, and that's the place value in question that I'm rounding to. Look to the right, it's 5 or greater. This is going to round to 460. And then 214, I look at that 1, look to the right, that's 4 or less. Oops, sorry. That's 4 or less, and we're going to round that down to 210 because that is 4 or less. So our estimation is going to be 0 plus 0 is 0, 6 plus 1 is 7, 4 plus 2 is 6. So our estimation is 670. But now we're going to use the standard algorithm to check how close our estimation is to the exact answer. So again, we're going to go ahead, I'm going to label these place values again, ones, tens, hundreds, okay? And we have 8 plus 4, so we know that 8 plus 4 is 12, so we're going to run right off the get-go into that similar situation Hunter ran into with 5 plus 7. So 8 plus 4 is 12 as well, but again, we can't put two-digit numbers in a single place value. So we're going to put the ones place of 12 being 2 in that ones place, and we're going to carry over that 1. That 1 again represents 10 groups of 1, because 10 groups of 1 is 10, plus that 2 is going to give us 12. But now we can add on that 1 as if it was in the tens place. Okay? So 1 plus 5 is 6, plus 1 is 7, and 4 plus 6 is 6. 4 plus 2 is 6, I'm sorry, and our exact answer is 672. So as you can see, our estimation was extremely close to the exact answer. Okay, let's go ahead and look at the next one. Just going to backtrack real quick. Alright, for B, so our estimation is going to be the sum of 253 plus 138. Okay, So 253, we look at the 5, it's going to look to the right. This is going to round down to 250. And then we have 138, we look at the 3, look to the right, 8 is 5 or greater, so this is going to round up to 140. Okay, we're going to take this sum, this is 0 plus 0 is 0, 5 plus 9, 5 plus 4 is 9, and 2 plus 1 is 3. So our estimation is 390 for letter B. Well, let's go ahead and do that standard algorithm sum. So 3 plus 8, again, we see this kind of situation here where our sum is 11, but we only can put one digit in that one's place value. So we'll put the 1 in, and then we'll carry a 1, which represents 10 groups of 1, because 10 groups of 1 is 10, plus 1 is 11. So we have accounted for it, but now we can add that 1 in the tens place as if it was originally in the tens place. Okay, so we have 1 plus 5 is 6, plus 3 is 9, and 2 plus 1 is 3. So our exact number is 391, which again is extremely close to our estimation. Okay, let's look at the next one here. So our next one is 209 plus 45. So 209 plus 45. Okay. So this is going to round to 210 because this 0 is the question in question. It's going to round up, and then 45 is going to round up to 50. So 210 plus 50 is 0. 1 plus 5 is 6. And bring down the 2. So our estimation should be about 260. And let's go ahead and calculate our sum here. So 9 plus 5 is 14. But again, we can't put that 2-digit number in that in one single place value. So we'll put in the ones place value of that. So that's going to be 4, and then we'll carry that 1. That 1 represents 10 groups of 10. 10 groups of 10 plus 4 is 14. And then 1 plus 0 is 1, plus 4 is 54. And you can also see this because if you were to take 0, 9, and add 45, or more simply 9 plus 45, you would get 54 from those two place values. So either way you kind of approach it, you would still get 54 with 4 being in the ones place and 5 being in the tens place. And then we just bring down the 2. And then our estimation is fairly close to 200, or our exact value is very close to our estimate of 260. Okay. Oops, keep doing that, sorry. Let's look at the last question here. So letter D is going to be 428 and 262. 428, we look at that 2, we go to the right. It's going to round up to 430. There we go. Sorry about that. And then 262 is going to round down to 260. Okay. So our estimation is going to be 0 plus 0 is 0, 3 plus 6 is 9, and 4 plus 2 is 6. So our estimation should be about 690. Okay. Now let's go ahead and do our algorithm here. So 8 plus 2 is 10, but again we can't put a 2-digit number or larger into one place value. So we're going to put the ones place of 10 into the ones place, which is 0. Now this tells us that that 1 again represents that 10 groups of 1. So this one's kind of a special case, not necessarily changing anything, but just that now there are 0 in the ones place. So there's no accountable values in the ones place because they're all in the tens place, which is represented by this 1 here. So this 10 is represented by this 1, but now we can represent it in the tens place alone. Okay, so 1 plus 2 is 2, or 1 plus 2 is 3, I'm sorry, and 3 plus 6 is 9. And we have 4 plus 2 is 6, and our estimation is actually the exact value in this case. Okay, alright, let's go ahead and jump to the next page here. So this one wants us to use the table above, estimate the total attendance for each day in your head, then use the standard addition algorithm to calculate the exact total. So if you guys would like to, what we'll do here is I'm going to kind of give a clue to where I'm about to kind of take a pause for a second. You guys can pause the video here. You can try to calculate the estimations in your head, and then I'll kind of go forward with how I would calculate the estimations, and then we'll use a standard algorithm for these, and then we'll kind of approach it that way, just to give you guys the opportunity if you would like to pause and try these estimations on your own. So for letter A, we're going to be estimating the sum of 125 plus 56. If you guys would like to try that, go ahead and pause the video right now. Okay, so we're going to go ahead and calculate the estimation for 125 plus 56. So 125 is going to round up to 130 to the nearest 10. So as I mentioned before, I'm just going to stick to rounding to the nearest 10, just so we're not rounding to multiple place values, and just to keep things a little bit more detailed with the tens versus the hundreds place. 56 will round to 60, so our estimation should be a sum of 190. So we'll go ahead and use that standard algorithm here. So again, 5 plus 6 is 11, but we can't put a two-digit number in a single place value, so this will be dropping the 1, which is the ones place of 11, and then we'll also carry that 1, which represents 10 groups of 1. So 10 groups of 1 is 10, plus 1 more is 11, but now we can represent that tens place in its own place value. So 1 plus 2 is 3, plus 5 is 8, and then we don't have to carry anything because 8 is a single digit number, and then we bring down that 1, and we get 181 as our exact value, which is fairly close to our estimate. Okay, so let's look at number B here. So for Tuesday, we have the we're going to be estimating the sum of 132 and 109. I'm going to let you guys go ahead and pause the video if you would like right now and estimate that to the nearest 10. Okay, so what we'll do here is we'll round 132 to 130. And again, these are going to be your place values that are of interest, so you want to just look at the rate and see if it's 5 or higher. And then 109 is going to round to 110. So 130 plus 110, 0 plus 0 is 0, 3 plus 1 is 4, and 1 plus 1 is 2. So our estimation should be around 240. So again, in this case, 2 plus 9 is 11, so just like the last time, we're going to drop that ones place 1, and we're going to carry the 1. That 1 that we're carrying representing a group, 10 ones, or a group of 10. Okay, and that now we can add that group of 10 in the tens place. 1 plus 3 is 4, and then we don't have to carry anything, so 1 plus 1 is 2. So this is 241, which is very close to our estimation. Alright, let's look at C here for the estimate for Wednesday. So we'll go ahead and calculate the estimation for Wednesday, which is going to be 127 plus 45. I'll let you guys go ahead and pause the video if you would like right now and take that estimate. Okay, so 127 is going to round to 130, and 45 is going to round up to 50. And if we take the sum here, our estimation will be 0 plus 0 is 0, 3 plus 5 is 8, and 1 we bring down, which is 180. So our estimation should be around 180. So 7 plus 5 is 12. We'll drop the 2 in the ones place, carry the 1, that 1 representing 10 groups of 1, or 10 ones. So that's going to be 10 plus 2, which is 12. So we see that again. So that 1 representing its own place value now. We have 1 plus 2 is 3, plus 4 is 7, and we get 7. We don't have to carry anything over, and then we just bring down the 1, and we get a value of 172. So that's fairly close to our estimate here. Now for D and E, what they want us to do is they want us to determine the estimate and then set up the algorithm. So it's not set up for us here, so they want to make sure that we're comfortable with being able to set it up in kind of the way that they have here from A through C. So for D here, we're going to first estimate. So we're going to look at Thursday. So we have 118 plus 115. I'll let you guys go ahead and take the estimate there. Pause the video if you'd like. Okay, so 118 is going to round to 120, and 115 is also going to round to 120. So again, just remember the place values in question, and then looking to the right and seeing if it's 5 or greater. And then if it is 5 or greater, the digit in question increases by 1, and then the rest of the place values to the right become zeros. So 120 plus 120 is going to be 0 plus 0 is 0, 2 plus 2 is 4, and 1 plus 1 is 2. So our estimation should be 240. Now let's go ahead and stand up our Our standard algorithm here is going to be, I'm going to set it up as 118 plus 115 . I'll kind of do what they did too. I'll put it into columns, but I'll also put little hats on my ones just to make sure. So this should be addition. There we go. And then, okay. So 8 plus 5 is going to be 13. So again, we drop the 3 because that's the ones place of 13. Carry the 1 because that 1 represents the 10 place of 13, but now it's in its own place value. And then 1 plus 1 is 2, plus 1 is 3. It's 3, but we don't have to carry anything over, and then 1 plus 1 is 2. So it's 233, which is very close to our estimate of 240. Okay. Let's look at letter E here. So we have the estimate for Friday. So we have, for Friday, we have 87 and 108. So for this one, I'll let you guys pause the video if you would like, and you can estimate the sum here. Okay. Our estimation is going to be 87 will round up to 90, and 108 will round up to 110. So don't let this, don't let the fact that there are two different multi-digit numbers here confuse you of what place value is in question. The tens place of each of these numbers is the place value in question. So we're still just going to look to the right, being the ones place. And since 7 and 8 are both 5 or greater, we're going to round up in both of these cases. So 90 plus 110 is going to be 0 plus 0 is 0. 9 plus 1 is 10. We carry that 1 for the same reason we have kind of done in the standard algorithm up to this point. And then 9 plus 1 is 10, but we drop the 0, being that 0 is the ones place of 10, and then we carry over the 10 to the next place value, and then 1 plus 1 is 2. And so 200 should be our estimate. So then we have 87 plus 108 take the addition, put hats on my 1s and 7s. There we go. 7 plus 8 is 15. So we're going to drop that 5, being it's the 1's place of 15. Carry the 1. 1 plus 8 is 9. But we don't have to carry anything. Keep that in mind, because 9 is not a 2-digit number, so we don't have to carry anything over. And then 1 we bring down as well. And our answer is 195, which is very close to our estimation of 200. Okay, so let's now look at the step ahead question. So the step ahead question, again, usually is getting us used to some more higher order thinking. So it's kind of going a little bit beyond and kind of a challenge question. So it says, write the digit that is missing in each box. Regroup if necessary. So what this wants us to do is say that if we add these numbers together, there's a digit missing in each of the following situations. And it wants us to figure out what we have to have in order for the sum of all of these numbers to be exactly what is based on the number that has to be in the boxes. So I'll kind of explain with letter A, and then we'll look at letter B, C, and D as well. So in letter A, we have 313 plus 249. Now if you guys would like, again, you can pause the video and practice with your estimations and just kind of see where you would ballpark this answer. But what we're going to do here is 3 plus 9 is 12. So as you can see, they dropped the 2 here because that's the 1 place of 12. And then we have to account for that 1 being carried. They didn't do that here for us. So now what we need to do is, now that we've carried that 1, again, that 1 being a representative of 10 ones, but now it's in its own place value. Again, remember, 1s, 10s, 100s. Now we can add it to solve for what this box should be. So 1 plus 1 is 2, plus 4 is 6. And our answer is 562, which is indeed what 313 plus 249 is. Okay? And so now you kind of get the idea. We have to figure out what the box is missing in terms of a value based on the algorithm and the sums that are going on. And if we have to account for something like carrying, that's what they really want us to kind of hammer home here, is that box is based on, you know, carrying from the previous place value. So 8 plus 9 is 17. They dropped the 7 being the 1's place of 17. But we have to account for that 1. That 1 is very important. Okay? And then 1 plus 5 is 6. Kind of get the same answer from letter A here. And 158 plus 409 is indeed 567. Okay? So now what they want us to do for C is 7 plus 9 is 16. So we account for that. And 16, so they dropped the 6, which is the 1's place of 16. Now we carried the 1, but this time we have to figure out what we need to add to 1 to get 8, because 8 is going to be the total sum of the 10's place. So if you have one group of 10, and you're trying to get to 8 groups of 10, how many more groups of 10 do you need? Well, let's see. If one group of 10 is 10, and 8 groups of 10 is 80, if I take 10 away from 80, that's 70. So this has to be 70, or this has to be 7, because that 7 represents 7 groups of 10, or 70. And one group of 10 plus 7 groups of 10 is 8 groups of 10, being representative of what this 8 in the 10's place shows us and tells us. Okay? And also, if you were to do the algorithm addition here, you would see that 607 plus 79 is indeed 786. Okay? Let's look at this last one here. So we have a square box in this first 3-digit number here, plus 817 is 993. So 6 plus 7 is 13. We carry the 1. But again, now we have the same situation as very similar to letter C. So what we need to do is we need to figure out that if I have one group of 10, which is the group of 10 from carrying from the 13, so that's one group of 10. I have another group of 10 from this 817. So that's 2 groups of 10 total. But if I have 2 groups of 10 total, and I need to get to 9 groups of total in the total sum of my algorithm, I'm missing 7 groups of 10. Because what I can do is I can say, well, I have 2 groups of 10, which is 20, but I need to get to 9 groups of 10, which is 90. If I take 2 groups of 10 away from 9 groups of 10, I get 7 groups of 10. And that will go right here in this box. So again, we can make sure that that addition works. 1 plus 7 plus 1 is 9. But that's representative in the tens place. So we can say here that 1 group of 10 plus 7 groups of 10 is 8 groups of 10, plus another group of 10 is indeed 9 groups of 10. And then we have nothing that we have to carry over, because 9 is again a single digit number, and it can be in that place value all alone. And then 1 plus 8 is indeed 9. And then if you were to take the sum, 176 plus 817 is indeed 993. Okay? Alright guys, well I hope this video did help you out. If you have any questions, as always, please don't hesitate to reach out and ask me. I'm more than happy to help you guys out with anything. If you have any requests for any kind of homework problems or practice problems, please also don't hesitate to send those my way. I'm more than happy to help you in any way that I can, okay? But as always guys, thank you so much for watching, and take good care, and we'll see you soon in the next video.